Hi everyone, this video is going to be all about significant figures, one of the weirder ideas in chemistry that proves to be really important as you move up to higher levels in advanced sciences. So the big idea here is that all numbers in chemistry are derived from measurements that we make in the lab. So that means numbers in chemistry are different from numbers that we see in math. And that's kind of a sticking point for people that find this concept to be confusing, is that the numbers may look the same, especially if you're thinking in a mathematical perspective, but in chemistry we treat them differently. And the way we treat them differently is by using this concept of significant figures to tell us how precise a measurement really is. And I'll use the term sig figs to kind of shorten down significant figures through the rest of the video. So I've got a little tool that you can use to help you count the number of significant figures in any chemistry measurement. And bear with me as we go through it because it will eventually tie back to reality. So in black is a very crude drawing of the United States. And I have an A listed on the right-hand side of the country to represent the Atlantic Ocean and a P over here on the left to represent the Pacific. But since we're talking about numbers and precision, what we're really going to be the absence or the presence of a decimal point. So as we consider significant figures, we're really going to be using the presence of a decimal point or the lack thereof to give us guidance as to how precise our measurement really is, what was measured and what's just estimated. So I've got a bunch of different examples of numbers, and we're going to use this overview to help us count significant figures. So the way this tool works is that if there's a decimal point present in the number, we're going to start on the left-hand side of that number and move right until we hit the first non-zero number. And at that point, every number to the right is going to be counted as significant and a measure of precision in that number. On the other hand, if there is no decimal point in the number, it's absent, we're going to start on the right-hand side of that number and move in until we hit the first non-zero number. And at that point, everything to the left will be counted as significant. And this tactic works like 99% of the time as long as you're writing numbers properly. That is, not sticking zeros out in front of numbers like 4. That's just silliness. So let's take a look at these examples and count the number of significant figures so we can get an idea of how precise these particular measurements are. In this case, I've made all the measurements of mass. So with 4 grams, I see there's no decimal point there in that number, so it's absent. I'm going to start from the right-hand side of that number and cross out any zeros until I get to the first non-zero number. Well, there weren't any zeros to cross out. I just stopped at the 4. I know everything to the left is going to be significant, but there's only one number there, so this has 1 sig fig. Now, if you look at 4.00 grams, mathematically speaking, yes, these two numbers are equivalent, but because these are chemistry measurements, we treat them differently because they have different values of precision. In this case, there's a decimal point present in 4.00. So when I'm counting significant figures, I'm going to start from the left, cross off any zeros I see until I hit the first non-zero number, but of course, there were no zeros out in front here, so I stopped right at the 4. Every number to the right is significant. That means this 4, this 0, and this 0 are all significant, giving 4.00 3 sig figs. You'll notice that even though these two numbers mathematically are equivalent, because we've included the decimal point, we've shown that this measurement was made using more precise instrumentation. We're more certain in its precision. Let's look at 0.05 grams. Again, I see a decimal point present, so I'm going to start from the left and cross off any zeros until I hit the first non-zero number. That means everything to the right is significant, but only this 5 is to the right. So this number only has 1 sig fig. If I look at this number, though, again, I see a decimal point present, so I'm going to start from the left, cross off any zeros I see until I hit the first non-zero number. Everything to the right is going to be significant, and that's this 6 and this 0. So in this number, there are 2 sig figs. This last number here, 10 point, you'll see this in your reference tables at times with seemingly random decimal points thrown into numbers. It's to help us think about the precision of that number. Here, because I've put the decimal point there, I start counting my sig figs from the left. I run into that 1, everything to the right is significant. That gives this 2 sig figs. You can imagine if I'd only written the number 10 without a decimal point. Let's take a look at that. 10 grams. There's no decimal point there, which means I start counting from the right. I cross off that first 0. This only has 1 sig fig because there's no decimal point around. So those little decimal points are thrown in there really as just a measure of precision on your reference table. So if you see them, don't get thrown off. The last idea I want to leave you with about significant figures is that all calculations done with measurements in chemistry, so think density, it's dependent on both mass and volume measurements. Those types of calculations are limited by the least precise measurement. So let's say for this particular measurement, I recorded the mass of a block to be 4 grams. Maybe I measured the volume of that block to be 4.6 milliliters or cubic centimeters. Were I to be calculating density, what I'd note is that my measurement of mass has 3 significant figures, but my measurement of volume only has 2 significant figures. So if I was to be calculating density using these 2 measurements, I'm limited by the weakness, this least precise measurement of volume. So my density should really only have 2 significant figures reported. So you're always going to use your weakest link if you're ever faced with a question that says how many significant figures should your answer have. I'm not going to hold you accountable to that when you're actually doing the calculations. Again, you can always round to the nearest 10th or 100th in my class. But if you ever face a Regents multiple choice question, say, that asks you how much should the calculated answer have, always just go by your least precise measurement. So I hope that helps you figure out some stuff with sig figs. Practice makes perfect for this kind of stuff, so keep trying and let me know how I can help.